Thank you, Sergey. Yeah, it's really great to be back presenting to the New York Web Perf group. It's been 5 years, and I just discovered minutes ago that I had copied the slide template from 5 years ago and forgot to update the year. So luckily now it says 2022 correctly. But yes, it is very good to be back. I am still talking about HTTP Archive, and for good reason. So we have a lot going on that has changed in these past 5 years that I've been working on it. The title of this talk is Discovering the Next Big Performance Opportunities, and soon you'll see why. I'm going to skip my intro. Sergey did a great introduction for me, so I'll just dive straight into it. When I'm talking about big performance opportunities, I'm talking about the scale of the whole web. But in order to tackle that big problem, let's break it down and just talk about the process of speeding up a single website. So site owners might have their RUM data or their CrUX data suggesting that their site is slow, or maybe it just feels slow. So what do they do to fix it, and what tools do they use? Lighthouse is one. It's very quick and easy. They give you a straightforward report where you can see some actionable opportunities that you can fix up. You can see your metrics from the lab. It's really approachable even for the less technical site owners to understand what's going on. There's a list of these best practices that they check for, and it's even prioritized, so you can try to tackle the biggest impact first. If you're using it in the context of page speed insights, you get the benefit of these Lighthouse audits alongside Chrome user experience report data. So that's real world user experiences to tell you how users are experiencing the page on one side, and then the other tells you how you can improve it. Can't talk about web performance tooling without mentioning web page test. It also has its own best practices section, but in my opinion, the biggest value is really in the lower level detail. I am going to trademark this if it hasn't already been, but I think it has a full body scan of the web page load, especially this waterfall view. You can really see how the page comes together over time and where the time was spent. It does require a bit more expertise to make sense of it, but it's worth it. The performance panel in Chrome DevTools is super useful. It gives you the ability to do real-time inspection of the page. You control the page, you can interact with it and see the way that your interactions affect performance on the page in both load time and runtime performance. This is for the more expert level performance people, but I think there's so much data here. It's very information dense, but there's a lot to learn. And so this general process of improving performance it's similar to the scientific method, where we figure out what could be optimized, we implement some change, we verify the optimization in some controlled environment, be it a lab or a field A/B test. And after we release it, we monitor it. We want to make sure that it works in the general case, and of course that there aren't going to be any regressions. Rinse and repeat. So how do we speed up the web? Surprisingly, it takes on a very similar process, but at the scale of millions and millions of pages. The Chrome team approaches the solution from two different angles. One is, what can we do to make the web platform better, faster? That's baking in new performance APIs and features, and of course, making Chrome itself faster. But the other side of it that I'm going to focus on today is about how we can work with the web ecosystem to improve performance more organically. You all are probably well aware that Chrome is heavily involved with the web standards processes. Two that have been in the news lately are 103 early hints and priority hints, specifically fetch priority equals high. These techniques have a lot of potential to improve performance, but they do, of course, depend on site owners instrumenting them and instrumenting them correctly. Chrome has also been tuning how and how often it restores pages from memory when a user navigates back and forward, also known as the BF cache. This is really great for performance, user perceived performance. The navigations actually feel instantaneous. But still, site owners must be BF cache eligible to benefit from it. There's a checklist of maybe 100 things to look out for. Google also has an OS business with Android, and owning that layer under the browser also opens up a lot of new opportunities to improve user experience on the mobile web. So page loads on Android just very recently got 15% faster thanks to these lower level optimizations. So efforts like these can be highly effective at moving the needle on some of the top level performance metrics. So let's explore a few of the ways that Google's working to make the web faster, more in collaboration with the broader ecosystem. And we call this at Google the scaled activation programs. And there are 3 prongs to it. The first is the content publishing or CMS and e-commerce ecosystem. These are your WordPress websites, Wix websites, GoDaddy, and in fact, all of those 3 have separate case studies on web.dev at web.dev/tags/case study. The other prong to this puzzle is the JavaScript framework ecosystem. And so we have a team of people working directly with framework authors like Next, Nuxt, and AngularJS. And this one is pretty new. We have an initiative focused on third parties, social, ads, video, tag management. Yes, even the ones including Google's own third parties. So we're trying to tackle the problems of software that is shared by millions of websites, let's say, and how could we bake performance best practices into these different ways that sites are built to move the needle forward on the web. So if we're going to focus on speeding up the web, how fast is it actually? And to answer that, we need a way to measure it, of course. And ideally, I think you all see this coming from a talk from me, public data sources that we can share and monitor together with the community. And HTTP Archive and the Chrome User Experience Report, or CrUX, are exactly that. Using these data sets combined, we can compare how websites are performing against Core Web Vitals. That's our benchmark for how we're going to measure this. Grouped by their common technologies. This is a screenshot from the Core Web Vitals technology report. And this chart alone tells a really interesting and complex story. Just taking a broad step back and squinting at the chart, you can see technologies are generally moving up and to the right, even for this default subset that's as I said, the default of this dashboard, but you can select from 2,000 of them. But generally, things are moving up and to the right. Some technologies are definitely performing better than others. You can see here Shopify and Wix are at the top of the pack. So now the natural question is, are sites getting better because their technologies are getting faster? Is it the web platform that's getting faster? I think the answer, it's very hard to answer, but I would guess that it's both. But it's not evenly distributed. Not all websites are enjoying these rising tides of web performance improvements. For example, BF Cache needs sites to be eligible for it for its users to benefit from it. How do we disentangle these two different things of ambient level performance improvements versus framework or technology specific? And whatever is happening, how do we ensure that this trend continues? So that's what I'd really like to focus on. And looking specifically at WordPress, there's kind of an interesting story. We can see that it's underperforming relative to the other popular CMSs, and the dark blue line that kind of is above it almost runs parallel. It's really interesting. So now that we know where we need to improve, WordPress is underperforming, how can we understand what to improve? So WordPress is 36% of the web. It's the single largest publishing platform. It's a huge lever if we want to improve performance. And here we can see that the LCP metric is where WordPress sites tend to struggle most. LCP, largest contentful paint. The other two Core Vitals metrics are first input delay and cumulative layout shift. Those are on par with the other technologies. The loading performance of LCP seems to be where WordPress is struggling. And only 35% of WordPress websites have good LCP, according to this chart. So not only do WordPress sites have significant room for improvement, but its popularity means that fixing it will have a huge impact on the web. So we know what needs to be done, or we know what we need to fix. What are the actual opportunities? How do we fix it? So this is a challenging problem because at the web scale, when you have millions of websites, what works for one website might not work for the other. We need a methodology that's going to translate and scale up. And the way I think we can prioritize it is by looking at three different things here. the reach, that's how many websites stand to benefit from some improvement. How popular are they? If we're going to talk about percent of navigations that have good core vitals or percent of origins. And how much of a nudge do they need to get into the green? If a site has a 10-second LCP, it's going to take a lot of work to bring that down. If they're kind of right on the cusp, maybe one of these improvements could really move the needle. The next one is impact. How much faster, quantifiably, can we make the ecosystem? And what's the likelihood of success? Which kind of dovetails into the ease of implementing these things. How technically challenging is it? What kind of support does it need to land? So let's go back to the basics and look at data from these types of tools to understand what the opportunities are. As has been discussed in the intro, the engine that drives HTTP Archive is Web Page Test. And within that, we run Lighthouse, now currently on both desktop and mobile pages. And we run all of these tests inside of Chrome, where we can log all these swaths of data, also coincidentally including page-level user experience data from the Chrome UX Report API. And one other benefit of Web Page Test is that it comes built in with Wappalyzer. And Wappalyzer is how we do all of these technology detections. It's open source. It's growing all the time. I think I said 2,000 before, but it's really more like 3,000 now because so many people are contributing to it, and it's great. And as soon as something lands in Wappalyzer, the next time we crawl a web page, we should be able to have that detection, and it should show up in a dashboard like this. So number one, quantifying reach. I'll say that it's relatively easy. We have Lighthouse data across millions of pages. We could just say what percent of pages are passing a given audit. And the limit here is really just the number of things that we're auditing. And we can measure how many sites stand to benefit from these improvements. The most prevalent performance opportunities from this graph seem to be script related. This is the render blocking resources, the main thread work. Also more than 75, this is WordPress websites specifically, more than 75% of WordPress sites could benefit from modern image formats like WebP. And I do also want to call out that just because an opportunity has small reach doesn't mean it's not worth our time. It could still be hugely impactful and super easy to fix, so why not? Low-hanging fruit, I would argue, is still a good place to start. As far as measuring impact, I want to offer a few cautionary words on how not to do it. So related to our CMS scaled activation work with WordPress, last year we were studying whether the implementation of loading equals lazy could have actually hurt WordPress performance. And during that exploration, this chart specifically was super helpful to suggest that there was something worth investigating further. So we dug deeper and we did more rigorous lab-based A/B testing to prove that yes, lazy loading the LCP image in particular made WordPress sites load more slowly. And that kicked off a whole long process of implementing a fix in WordPress and verifying that as well. But I do want to warn you, don't misread this chart. It's not saying lazy loading makes your site slower and you shouldn't use it. It's saying that misuse, especially on the LCP image, can hurt performance. Also, we need to consider different biases. Certain sites with specific performance characteristics might use it. We're looking at two different cohorts of the web, those that use it and those that don't. There is also nothing here to indicate what sample sizes of each we're looking at. So ideally, we could run A/B tests in the field on real websites and not just in some simulated environment, and turn off lazy loading and see how that affects real user experiences. Unfortunately, we can't do that at this scale. There are millions of websites outside of our control, but the next best thing that we could do is to watch sites over time and see if they move between these cohorts. And then we can see how does their performance change. But this kind of leads us into another anti-pattern of our analysis, and that's the before and after time series. So in this chart, we're looking at Wix performance compared to the general web. Let's say Wix fixed some big Lighthouse performance audit in May 2021. That's this red line here. Naively, we might say that the percent of good core vitals was, at that point, 23%. That's the percent of Wix websites in May 2021, and today it's at 40%. So rough math, it's about 75% better. But if we look at this darker blue all line, that got better too. Remember all of those platform level changes I mentioned at the top? So actually, as it turns out, in May 2021, the same exact time as this hypothetical example, Chrome changed the cumulative layout shift definition. It used to be unbounded, and then kind of a clamp was applied for a fixed point in time, a fixed duration. That, by definition, increases the percent of websites that are going to meet the good threshold for CLS. So that will have this rising tide effect across all websites, including WordPress. In June 2021, Chrome improved the way that it does double tap on mobile to zoom. There used to be a delay there, and that will improve FID performance in the way that we measure it here at scale. Sites didn't have to change anything. Nothing changed in Wix during that time, but everybody benefits from changes that land in Chrome itself. In January 2022, Chrome expanded BF cache coverage. I believe it was more tolerant to sites that set cache control no store. That improves significantly. Very fast performance or very fast experiences on the web. In this specific case, I don't think Wix qualified for that because Wix is not BF cache eligible because they use web workers, but that might be changing. And then in May 2022, Chrome launched those performance improvements on the Android platform. So each of these kind of bumps in the darker blue line correspond to something that happened at a huge scale to move the web as a whole. We do see that reflected as well in these technology-specific lines like WordPress, Wix, and others. So we have to ask the question, why are these sites getting faster? Is it something they did or was it something else? How do we disentangle those? So it's great that the web is getting faster. These are user-perceived performance improvements. But for our purposes of dissecting specific improvements or opportunities for improvement, we need to have more granular data. We need to kind of separate them as best we can. It really muddies the water if we're looking at a span of time and a lot has changed. One thing that we could do, and we're getting on the right track now, is normalizing to some baseline. There are ambient influences that happen on the web, be it browser level changes, be it user changes. Maybe people, due to COVID time, going from work to home has affected their performance speeds, maybe because in-office internet tends to be faster than home internet. So there are all of these different ambient changes that can affect this. And if we set the baseline to all and only just basic subtraction, look at how Wix performs, we see a really, really interesting pattern here with three very distinct inflection points. The first is in August 2020, their performance just absolutely took off. And we know from one of their case studies that has been published, web.dev/Wix, this is about the time that they really started investing heavily in performance. So that lines up. What I didn't hear too much about is something that happened in August 2021. There seems to have been some regression. That is a lot harder to pick apart when a lot of other things are changing at the same time in a graph like this. But just a few months later in January 2022, it seems like things got back on track and now they're moving in the right direction. And now they're actually outperforming the web as a whole. So this is a very, very clear example of a CMS who is investing in performance. And it's great to see that more clearly illustrated in a chart like this. So this indicates a way that we can structure our research to more specifically pull out changes that are due to the technologies themselves versus ambience. Okay, then how do we normalize a specific audit? We just normalized an entire technology. So here's one approach that we've developed. Measure the change over time. So we can quantify how much performance changed when a page went from failing to passing a given audit. We can also compare against a baseline by using the pages that went from passing to failing. Because that data is incredibly useful if we assume that going from failing to passing and passing to failing kind of has equal and opposite effects on the performance of the page. So if the entire thing kind of shifts up, then we know that the baseline has moved. And to normalize, we just do simple subtraction. Subtract the performance effects of the audits that start failing from the performance effects of the audits that start passing. If there is a rising tide effect that's lifting up both of these pass-fail groups, that should cancel out. which numbers we do this abstraction on is also part of the subjectivity of setting up an analysis like this. If there are so many websites, which number do we pick? So in our case, we're picking the 75th percentile from each, not website, but each web page. And then from that entire group, we're taking the median 75th percentile. This approach is not without its limitations. So first of all, this is not an A/B test. With the right setup, a site owner could run their own A/B test with and without the feature enabled to directly measure the performance. We can't do that, but correlation is the next best thing. Another problem is audit entanglement. Sites might change more than one audit at a time, and that definitely affects how they appear in this type of analysis. We don't necessarily know one audit caused it, or maybe the fact that both audits changed at the same time gives us a little bit of ambiguity. Another really big problem is sample sizes. If we have too short of a time window, not enough sites will be able to flip that audit status. Sites don't change that often, but too long of a window, and then we get all this extraneous performance fluff that affects the data. We've kind of used 1 year as a sweet spot, but we're still experimenting with it. Also, technologies could have really low adoption. So that just is a multiplier that means that we're going to get less and less useful data. So this works really great for the larger technologies. Another problem is CrUX coverage. So I mentioned that we're trying to look at page level data, not origin level data. Due to the way that HTTP Archive sources its websites from CrUX, we do have origin level data for all of the pages. But what's going to be most useful for this analysis is page level data, because page level is where we're doing these audits. We're looking at the page to say it's failing the modern image format audit. And page level data, by definition, is just going to have fewer traffic or fewer data points than the origin level data. HTTP Archive recently started crawling secondary pages 1 level deep from the homepage, which is great, but there's not enough historical data to fill in that time window yet. And the CrUX coverage problem gets even worse for secondary pages, assuming they're not as heavily trafficked as the homepage. Similarly, with HTTP Archive recently starting to run Lighthouse on desktop, we're not going to have that historical data for the Lighthouse desktop analysis, which is a really big blind spot because mobile and desktop have very different performance characteristics, especially in Lighthouse where we have a specific type of test configuration for mobile devices. The connection speed is slower, the viewport is smaller. So different types of layout shift and loading performance issues are going to be very different across these two types. The third factor is ease of implementation. This is more of an art than a science, but I'll argue that it's one of the easier things to do. It's a tractable problem, but it does depend a lot on the circumstances. Are we talking about a one-line change, or does it require a huge refactoring? If the platform like WordPress already supports lazy loading everything but your LCP, it's a relatively small leap to go from there to, while you're at it, set fetch priority equals high on your LCP, because assumedly there's going to be logic to identify a probable LCP candidate. Also, does it require deep technical expertise to pull it off? Is this something the core team can implement themselves, or does it require a lot of outside collaboration? What kind of maintenance does it need after launch? Are things continuously evolving? Do we need to hold its hand over time and keep updating it, or is it kind of a set it and forget it type of thing? Then there are more complicated interpersonal questions like, what kind of relationship do we have with that ecosystem? Are they willing to take our advice? Will they accept our pull requests? And more to the performance culture, how open are they to investing in performance? Do they see the business value? Do they see it as a competitive advantage? For example, 3 years ago, landing performance improvements to WordPress core might have been an uphill battle. But today that culture has changed and there's a core team dedicated to performance. So the wheels have been greased. We can more easily pitch performance improvements and they're very receptive to it, which is amazing. Okay, so that's enough methodology. What are the next big performance opportunities on the web? So I'm going to give you all a big disclaimer. This talk is more about the process than it is about the data, because this analysis and this investigation is still ongoing. Our coverage, as I mentioned, is still expanding. The number of websites in the data set nearly doubled a couple of months ago. So that gives us a ton of useful data starting from that point a couple of months ago, but we need that time window to fill in. We're also trying to work on more audits in both HTTP Archive and Lighthouse, things that we can measure all of these best practices. So we do have some early data, and I'm happy to share that with you as a proof of concept. First, let's look at the JavaScript framework ecosystem with React. So React has 670,000 sites in the data set. I'll just break down what we're looking at here, starting with the columns. On the leftmost side, we have the Lighthouse audit, and it's annotated with the corresponding Core Web Vitals metric that it influences. Next, we have the reach. This is the percent of React sites that are currently, as of this month, failing the audit, or whatever month it was when I ran this data. Next is the impact. This is kind of hard to explain. It's those lines and emoji that are moving around over time. So this is the estimated percent change to the Core Web Vitals metric that we can expect when passing the audit. I then have calculated something called the reach impact score, just to make it easier to sort this list to prioritize it. And if you're interested, it's basically a 4-to-1 relationship between the reach and the impact. So that way reach is 4 times more likely to influence the sort order. Onto the rows of what this is actually telling us. Note that 4 out of the 5 top opportunities are all FID audits. That is super interesting to me on its own. The first is boot up time, then main thread work, and then third-party summary, which is perhaps outside of React Core's control, so maybe not applicable in this case. But the next one is DOM size. That seems pretty applicable here. So pause here. Wait, does React actually have a FID problem? Not really. So 94% of React sites have good FID on mobile devices. That's really good. On the other side of things, 41% of React sites have good LCP. So maybe we should be focusing more on LCP. But maybe not, because if we look at the INP metric, this is interaction to next paint, kind of seen as the successor to FID. I'm not saying it's going to be a Core Web Vitals metric officially, but it's definitely something to keep an eye on. 35% of React sites have good INP on mobile, compared to 94%. So maybe this data is onto something, that there are actually responsiveness issues in React. Going further down the list, unsized images are affecting more than half of all React sites. That can improve CLS by 18%. Further down the list, the viewport audit. Only 1% of sites are affected, so that's really low reach. But it's relatively high impact at 36% reduction to FID. It's also a one-line fix, so it's super easy. Why wouldn't we try to just bake that into React Core somehow and encourage the React community to adopt something like this? So this is where you just have a meta tag in the head that says this is how you handle mobile viewports, and it eliminates that double tap to zoom problem. We also see that there's an unused JavaScript audit where it's affecting 84% of React sites, but it's not very impactful for the sites that do fix it. It only results in, at the median, a 2% reduction in the LCP score. So in the LCP performance, so that is what gives it its low reach impact score. I know this is a lot of data, but it's just good to go through at a high level. We just saw the React stats where FID and JavaScript was very high up on the list. Now we're looking at WordPress, and the story changes, which makes sense. There are different ways of building websites, and WordPress is enormous. I'm sure there's React on WordPress, depending on your themes and plugins. But looking at sites that are built with WordPress as a whole, of which, by the way, there are 2.7 million of them in the data set, it's a very different top 5. So the first 3 are all LCP related. Render blocking resources affect 87% of WordPress websites. That's over 2 million websites affected by this audit, with an estimated LCP improvement of 12%. Slow server response time, 55% reach, 16% impact. So this is one that I have always suspected is a huge issue with WordPress, given the very diverse hosting landscape on WordPress. Some of you might be familiar with my Is My Host Fast Yet microsite. Measuring ease of how to fix this problem is extremely complex. The reason why people have slow hosts isn't because they don't care about performance or they want slow websites. It's because they're cheap. It's more affordable to be on shared hosting. If we want to fix this problem, we can't ask site owners to shell out more money to go on a faster host. That solution does not scale. So we really need to brainstorm more creative ways to solve this problem at scale. The next LCP audit at the top is font display. This is the way a web font will swap in as it loads. 73% of WordPress websites are affected, 12% impact. Again, similar to the viewport audit, the ease here should be really straightforward. At least in my experience with Google Fonts, it's just adding a few characters to the font request, and then Google Fonts will take care of the way that the fonts load in. Also in the top 5, we have 2 FID audits, boot up or JS execution time, 63% reach, 12% impact. Main thread work, 85% reach, 8% impact. In both of these cases, I'm going to make a guess to say that this is having to do with excessive plugins. I have looked at a lot of WordPress websites and spoken to a lot of WordPress developers. I've been, in just a couple of weeks, I'll be at my 7th or 8th WordCamp. WordPress site owners don't consider themselves technical necessarily. They're working in an editor where they just have content and they want to give it to their consumers. The website itself is a means to an end. So when they have a problem like, I'd really like a way to show some images at the top, they might pick a carousel without necessarily realizing it hurts their performance. I would say it's not the site owner's fault. It would be great if everybody who had a website cared deeply about web performance. But the truth is, half of websites are built with a CMS. People are so far removed from the code. They just want to have stuff out there on the web. I would say it's the responsibility of the tool chain, the developers who write code in cases like this, the WordPress core team, the plugin authors, to care more about performance. And this requires a lot of cooperation. So the plugin authors need to not only care about performance, but even people like the marketplaces where site owners can shop or discover plugins. It would benefit everybody if there was something like a performance score in there where you could say, oh, yeah, this plugin does solve my use case, but it might also hurt performance. So I'm going to go with this other one that solves my use case and doesn't hurt performance. That, I think, could make a really big impact. And it has to do with the culture of performance. Anyway, getting off my soapbox. CLS, there's only one CLS audit here, by the way. That speaks to the need for different types of best practices that we measure in Lighthouse. But anyway, unsized images didn't make the top 5, but it does seem like a big opportunity. There are 64% of WordPress websites that could benefit from it for an 8% impact to their CLS. It should be an easy fix, especially for a publishing platform like WordPress where you control the markup that gets injected onto the page. Adding height and width attributes seems like it should be an easy problem to solve. But CLS isn't where WordPress struggles. Where does WordPress struggle? So 28% of WordPress sites have good core vitals. Already we've established that it's a pretty low baseline. When we look at the individual pass rates for each core vital metric, 36% good LCP, 96% good FID, 73% good CLS. So we can stop right here and just say LCP is the bottleneck. We could also break down LCP into time to first byte. And I love the fact that we have this in the CrUX API now so that we can get page level data. The origin level data in the Core Vitals technology report tells us 21% of WordPress websites have good time to first byte performance. I think it's easy to see server response time is a really big problem in this ecosystem. And that's thanks to data like this, different ways of slicing CrUX and HTTP archive data to tell us how to think about performance improvements. So what's next for this type of research? first of all, see the limitations tab. We have a lot that we need to resolve and at least mitigate before we can productionize this. We do have this preliminary data that I've shared with you today across many different technologies, and teams at Google are already looking at it and using that to inform their prioritization. I do think, though, that we need to wait and see until we have more data in order to release this as any sort of public tool without all the disclaimers attached. HTTP Archive is increasing the amount of data, both in terms of the raw number of websites that we cover, but also the secondary pages, so crawling beyond the home pages, and also the desktop testing in Lighthouse. The other thing that we need to do is revisit all of the current best practices that we're auditing for each of these core vitals, both in Lighthouse and in HTTP Archive itself. We have custom metrics in HTTP Archive where we can almost prototype a Lighthouse audit and get an indicator what % of websites are doing well in this particular thing. And it's really lightweight process to submit a new custom metric. And finally, we need to make the data more easily accessible. I think that's what you're all here to find out, which is, yeah, the data is great, but how can I get my hands on it? And I think especially for the technology ecosystems themselves to be able to access the data and monitor it over time, to not only see what are my future opportunities, but how am I doing against that thing that I supposedly fixed in the past? And I'm thinking of this almost as a companion dashboard to the Core Vitals Technology Report. So you can, on one hand, discover where your opportunities are, and then on the other hand, you can see what the opportunities are. If all of this sounds interesting, we're working on this out in the open, so feel free to contribute. It's open source analysis being done on public data sets. You can find the queries on GitHub. That is in the CWV Tech Report repository under HTTP Archive. Feel free to start a discussion or an issue even if you have suggestions to improve our approach. The BigQuery data is all public, and we're going to be materializing these tables to the HTTP Archive .core Web Vitals dataset. But do be aware that costs do apply to use BigQuery beyond the free 1 terabyte per month tier. We're also looking for people to help us improve the list of opportunities that we check for. If you're able and willing, please contribute your feature requests to Lighthouse Core. Please contribute new custom metrics on HTTP Archive. It's, as I said, great for prototyping new or future Lighthouse audits. And if you can't contribute, we'd still love to hear your ideas. Just open up a discussion thread. That's all I have. Thank you all for your attention. And I'm happy to take any questions.
A little outside of the data itself, but I've been spending some time in data analysis recently, and your talk is full of a lot of analysis, and I find myself struggling with understanding data. And even I can imagine how new folks coming into the space feel as well, because it's a challenge. It requires a lot of statistics, understanding of performance itself. I mean, your talk like described many of these challenges, right? Do you have any resources or pointers on how we all can up our game and get better at analyzing data?
I am still learning. Edward Tufte has an amazing course on data science and data visualization. I have not taken it, but everybody recommends it to me. I wish I was a better statistician. It's a really hard field to get into because it's very mathy, and it's hard for me because when I do analysis like this, I don't know when I'm doing it wrong. I might come to the wrong conclusion and not know it. And once in a while, somebody will correct me, and I have a really nice learning opportunity. So if anybody sees anything wrong here, let me know. But for general like performance analysis learnings, I have a book I can recommend you, but I'm mostly just joking. I think the community has a ton of great resources. Maybe the HTTP Archive discussion forum could be a good place where people share different resources and best practices. That's somewhere where people can share queries specifically, but I would love to see it more generally into data science as well. Maybe machine learning is the next place that the next frontier for us to cross with a data set this large.
Yeah, I feel like specialized data analyst profession might be emerging for this. At least I personally feel I'm not qualified. not qualified enough. Let's put it this way. I struggle the same way every day. Feel like an imposter.
We're all doing our best.
Yeah, exactly. Question from Henri, like, will we have slides? Yes, slides will be shared. Absolutely. Question from Rocky. So Wix Spotify improved core web vitals at scale due to their reach. Did they see any evidence of improved conversion across the merchant base? Are they willing to release case studies? Do you have a question?
The question was about Wix.
And Shopify, Wix Shopify.
Oh, okay.
Like basically large platforms.
I am reading the web.dev/Wix case study right now just to see, did they include conversion type metrics? I think it was mostly about what they did to improve performance. No. This is kind of the holy grail that we're looking for to complete the circle of why web performance matters. We have an entire partnerships team at Google that reaches out to these large ecosystems, convinces them to care about performance. And then the thing that we're looking for at the end is, so what did you see in the end? Not just platforms like this, but also individual websites. What did you see in the end in terms of your business metrics? Did it improve conversion rates or anything like that? So we have this case studies tag on web.dev. I encourage everybody to go there. It's even in the header. We will publish things like that there, and we're continuously looking for more. So if anybody watching this has improved core web vitals and saw performance improvements correlating with business improvements, let us know. Let's publish a case study, because that really helps a lot of people convince their leadership that performance is important to focus on.
Yeah, and also want to mention WPO stats, also share there. Exactly. If you find some other study. I mean, it's a team effort. Like, we all can collect that information. And I see Henri also mentioned a session he's going to run with Shopify specifically. What is it, next week or something like that? Might want to join that. I see CEO on the team and a few other folks from Shopify.
There's also, I want to mention like an indirect effect of performance improvements. Wix has been really good at this, which is using the public data, this shared dashboard with Core Vitals Technology Report, and using that as part of their marketing campaign. Other CMSs have done this as well. Like, look at me compared to my competitors. And it's good for getting more websites to sign up with their service. So even if it's, I mean, in a way, this is a business metric being the number of websites on my CMS. So yes, we can measure that too. And I even saw Core Vitals Technology Report being used in Wix's quarterly finance report type of thing. That's how important it is for investors, they feel. So performance is super important. And even if we don't have, for an individual website to improve performance, what was the effect on conversion? There are still all these other indirect metrics that we could look at.
I see a few folks asked about the book and the course by what's his name? Edward Tufte, right?
Tuft, yeah.
Tuft, yeah.
T-U-F-T.
Yeah, Paul just shared the link to his courses and books. I do have 4 books from his collection too. Yeah, I'm probably into 1.5 of them, but yeah, it's a lot of the books. Amazing books. A lot of this will require our collective thinking of how to visualize data. It is challenging. Yeah. Okay, another question. Rick, do you think it would make sense to create an audit to check for CSS class name sizes? I just fixed an issue regarding that on my app, and it reduced HTML and CSS size a lot and improved LCP.
Maybe. What I would say is, let's instrument in HTTP Archive a custom metric that measures it, and then we can run some correlational analysis to see, do sites with long class names or a lot of extra HTML correlate at all with poor performance. And if that's true, maybe that is something we need to surface at a higher level. Or if it's just kind of a coincidental stat with having very large HTML in general, we could kind of generalize the audit to say, I mean, this is what the DOM size audit is already. Well, that's more about number of nodes than the bytes itself. So maybe, yeah, a byte-based version of that could make sense, focused either on styling or the markup itself.
And remind us again, how can Rafael like submit that request? Where he can go to do that?
Yes, so on GitHub, there is, I'm not sure if I can chat. I'm going to paste it anyway and see if it goes through, but github.com/HTTP archive, that's our project name, /custom-metrics.
I think you shared it only with hosts and panelists. I'll reshare it real quick.
Oh, I see. Thank you.
Everyone, I just did. Okay, awesome. Thank you. Thank you. Oh, and obviously Mel just shared it right before that. Thank you, Mel. Sorry, I need to read it more faster.
All good. We're all just excited about it.
Yeah, yeah. What else do we have?
I apologize if I missed any questions mid-presentation. I was not paying attention.
No, we covered almost everything.
Okay.
But now, yeah,
Great.
that went very well. So I have one question. How, like you mentioned, obviously analysis primarily based on public data sources from Google in HTTP archive and CrUX. How can a company that wants to invest into performance do deeper analysis of their own data? Is there any way for them to do that, and what do they need to invest in?
The first answer is get real user data. It's a little too easy to overinvest in lab data and get led astray. You really need real user data to inform what the problems are that real users are experiencing. So get some RUM. If you don't have some RUM, get some CrUX. That's a good backup. And Barry Pollard, my colleague, just wrote a really excellent blog post on the differences between RUM and CrUX and why it's necessary to have your own RUM solution. A lot of it comes down to the ability to drill down. CrUX is by design anonymized, so there's only so much granularity we could give you. There are thresholds that users need to meet in order for their data to be packaged up in the report. So having your own private RUM data is crucial. The other thing I would say, if the question is more about what do I need to fix to improve my performance, lab data starts to become really useful. That will give you a tool like Lighthouse or Web Page Test, can give you some opinionated guidance on where the problems are. But the next step is really A/B testing. You could do this in the lab with Web Page Test, but I would say what really, really is powerful data is field-based A/B testing. And unfortunately, in the web development world, field-based A/B testing is really hard to do well. The easiest solutions are the ones that do it the worst. So you have to be really careful. And in lieu of that data, lab-based A/B testing is still good. Just to say, if I were to improve performance in this way, or if I were to improve some feature, how might that affect real users? And then using that to inform this MOM, measure, optimize, monitored loop. To say, yes, we're ready to launch this publicly, and continue to look at your stats. So after you've changed anything performance-wise, continue to look at your RUM data, continue to look at your CrUX data. We have the CrUX dashboard where anybody could see their change over time for all of the core vitals metrics. So I would strongly recommend just adopting some sort of a process for each of those MOM steps.
Yeah, and I don't know if I want to chime in with the web page test promotion here, but
please do.
Want to do quick experiments and for the opportunities. I know I used both words. You can use web page test's new commercial offering for testing the changes to your website without actually implementing it. It can be a very good first step for you to start that journey in optimization. I see that Paul shared the link to that Barry Pollard's article about CrUX versus RUM. Very useful article, I appreciate. Question from Henri to you, Rick. Will you be sharing this data at WordCamp US? And what was the feedback at WordCamp EU?
I hope so. I hope we'll be able to share it. I'm only hesitant because we're still kind of coordinating what the presence will look like. I'm not giving a talk at WordCamp. What I've done all 5 years that I've been doing it has been staffing the Google booth and helping site owners audit their performance. I think this type of data is most useful to people like the WordPress core team, the developers who contribute directly to it. For the individual site owners, it's less useful for them to know that websites in general could get faster if they did something. They're really interested, like, okay, so just tell me what plugin I need, I'll install it, and hopefully that makes performance faster. These are the people who consider themselves non-technical. So number one is just raising awareness of how fast is your page, because they care deeply about this from the SEO angle. Am I meeting Google's page experience signal requirements? So once we get past that, they're like, where's the problem on my site? Oh, it's my host. I hated them anyway, so let's switch to this other people. Like that's a conversation that comes up a lot. But a lot of the time, it's basically just raising awareness with these attendees. The feedback at WordCamp EU was exactly what I described. What is CrUX?
Yeah.
Chrome User Experience Report. I can link you to the. Actually, yeah.
We shared the link to Barry's article again. Dmitry, you can go there. There are probably links to specifically Chrome User Experience Report. And yeah, sorry for all the abbreviations. Some of us get so used to them that we just forget that they are not obvious.
Yeah. I just shared a link to the new and improved CrUX documentation where you can learn everything you want to know about it.
Alex is asking, Chrome Lighthouse counts CLS as page loads without scrolling, but the Googlebot Search Console data is based on the user's full interaction with the site, including scrolling. I don't see here the question there.
It's true, yes. Lighthouse by default does not interact with the page. And that is a huge source of confusion. There is, I think, another article about that we could pull up about lab versus field data. And for that reason and many others, including for the fact that INP is becoming a thing, we have a very hard time measuring FID as it is today in the lab. So we've been using total blocking time, TBT, as a proxy metric. So one of the things that I'm really excited about is the push for more user emulation in a lab environment. A web page test just has this recorder extension. I'm really excited to try that out. So recording real user interactions, playing them back in a lab environment. And in theory, that should generate the same types of layout shifts in a lab that a real user would. And so you can track that over time if that's your thing. Any other sort of lab synthetic monitoring that you might do.
And I know Alex showed a script that he wrote for web page test in particular, I believe manually to do some scrolling, but this extension is, yeah, that might be a new way of doing that in much more simple way these days. I didn't try it myself yet. I mean, I installed it, I poked around, but didn't go deeper. Maybe at our Meet for Speed in September 8th, we can do that. Yeah. Okay, while we wait for a few more questions, Mel and I have an announcement that we did partner with SmashingConf, a front-end and design conference that comes to New York in October, second week of October. And we got a 25% discount link for all of you. So if you want to join, it's an amazing conference. I know Henri is presenting or hosting. I forgot, like he's always there. Or he's awesome speaker. And I love this. And Vitaly Friedman, who is running this conference, also is a big web performance proponent. So Mel just shared the link if anyone wants to click that. You will get 25% discount on the conference. Again, it's in New York. Whatever you are local to New York or join us remotely, I mean, you're welcome to fly in. They actually do have another conference in Europe, I believe, right? We don't have a discount for that though. You might want to check out the folks there. But if you're in New York, I hope to see you all there. It's amazing experience. And we will be sending another email, by the way, with a follow-up, so you can ask for that later in the chat, or just look out for the conference in Toronto question. That's actually probably a question to Henri, who is in the chat. Maybe he knows good conferences in Toronto, being our Toronto rep. Web performance rep in Toronto.
There's a great Spotlight Web Performance Conference in Toronto, hosted by Henri.
There you go.
I'd love for that to happen again.
All of our enterprise sites load over a dozen connections to different Google services, killing loading perf. Is there a strategy Google recommends for loading all of those tags? I know it's always a question.
Well, everything is situational dependent. I would love to see a waterfall view of this particular site to give any concrete advice, but generally, the web performance guidance is delay load things you don't need immediately. And if there's a way to do that through your tag manager, or if you happen to be using one, then definitely look into that. As far as I know, there is a way to say this is critical to the page load, I need it immediately, or not, and so that it gets deferred and it doesn't tank your performance scores. There might be more specific guidance on web.dev. If so, somebody please share the link. I'll also look for it.
Yeah, I know for sure tuning up your trigger points in Google Tag Manager in particular can help, and picking your tag management solution that can help you do more control, giving you more control, can help with those, in my experience.
Paul Calvano, thank you.
Alex is pointing out that Cloudflare has some service called Zaraz. Sounds very weird in Russian, by the way, or Google Analytics server side. Yeah, there are a few services, by the way, like a few third parties. I want to point out, not specific to Google, but in general, few third parties recently started to move towards server-side data collection, meaning that either you collect the data and send over, or they create some kind of integration that Alex is probably referring to collect the data. So don't assume third party has to be front end. Don't make that assumption. And these days, it's easier to say than all these years before.
Thanks, everyone.